All right, today we're going to be solving some trig equations, right? And the one that we got to solve today is going to be 2 tangent squared theta plus tangent theta is going to be equal to 0. So they said find all the angles from 0 degrees to 360 degrees because of the underline also equal to 0 degrees but less than 360, not equal to 360. That satisfy the equation below to the nearest tenth of a degree. So this is going to be a raw breakdown video. Not wrapping this video, but I'm just breaking this down step by step. Okay? All right, first things first. What we need to do to make it easier for us is do a substitution. So I'm just going to say let x equal to tangent theta. Cool. Once I do that now, I'm going to rewrite my expression, and instead of having tangent theta, I'm going to have x in its place. So if I have tangent squared theta, that's going to look like 2x squared plus tangent theta, x equals to 0. Now that I have that, I want to go ahead and solve this equation now, which now features my x, right? So if I'm solving this equation, the next thing that I need to do is say, wait, I got an x squared here. So I can't just pull x by itself. I'm going to need the factor. All right, cool. So first step in factoring is always what? Greatest common factor. You're right. So let me do that. I'm going to skip a space, go to the left. I'm going to put my x on the outside. Let me switch the colors up. And I'm going to divide by x. 2x squared over x is going to give me 2x. And then x over x is going to give me positive 1. Still equal to 0. Now that I've factored, I want to go ahead and set each factor which has a variable equal to 0 separately and then solve for x. So I'm going to do that. This first factor, x, has a variable. I set it equal to 0 and solve. Lucky for me, this is already solved. Then I'm going to take 2x plus 1 and set that equal to 0 as well. Now what? Now I got to go ahead and solve for the variables. This one is solved, leave it alone. This one, okay, we're going to subtract 1 on both sides. This cancels. We're going to go through, and then I'm going to get 2x equals to negative 1. Right? From here now, I'm just going to go ahead and divide both sides by 2. And then I got x equals to negative 1/2. Okay? So let's stop and take a look at what we did as a whole, right? And see how we got to this point and what we're going to do next. We started out with 2 tangent squared theta plus tangent theta equals to 0. I let x equals to tangent theta. I did that substitution. I got 2x squared plus x equals to 0. Then I factored it out, used my greatest common factor, put the x on the outside, divided by. When I looked in its parentheses, there was no more factoring to do. So because there was no more factoring to do, I knew I was able to move on. Cool. I set each factor equal to 0 and solved. Well, each factor that had a variable. So x was equal to 0, I solved it. And 2x plus 1 equals to 0, I solved it. Now the next thing we're going to have to do is substitute back. So just the way we let x equals to tangent theta, now we're going to do the reverse. So zoom back in. So then now, based on this, I'm going to say that tangent of theta equals to 0. And then over here, I'm going to say that the tangent of theta equals to negative 1/2. Cool. Now that I'm here, I can find the angles. But what do I need to remember for this part? I need to remember my inverse functions. So if you remember from previous assignments that we did, right? Before, what we were able to do, we used to be able to just say, hey, tangent or any trig function of an angle is going to give you a value. But we had our inverse functions that we used before too, where we can say the tangent of -1, which is the inverse, or sometimes you see it as arctan, of the value gives you back the angle. So whenever you have the value and you're trying to find the angle that corresponds, you use this function here. And it's the same for the other trig functions. It'll be cos to the -1, sine to the -1, and so on and so forth. So that's what we're going to do right here. I'm going to say tan to the -1 of 0 now is going to be equal to theta. You got me? Cool. Now, if I plug this into my calculator, very straightforward, it comes out to 0. So we like 0 degrees. Ooh, I got the answer. But I got to remind myself of one thing. They asked for all the values from 0 to 360 that satisfy it. So because trig functions repeat as they go from 0 to 360, there may be more than one angle that's going to match up and have a value of tangent that's going to be equal to 0. All right, so what I need to do? Okay, so the next thing I need to do is I actually have to be familiar with my 3 main graphs. Okay, so let's go through that real quick to make sure you have familiarity with it so you can handle it. The primary reason you're going to need to be familiar is when you're going to get tan to -1 equal to 0, or some trig function to -1 equal to 0, or some trig function to -1 equals to 1 when you're dealing with sine and cosine. Those are going to be the only cases that it's going to be important for you to kind of be familiar with the graph. All right, so let's talk about a tangent graph. Tangent graph, I'm going to put it in terms of degrees to make it simple right now. It's going to be 180 here. It's going to be 360 here. It's going to be 90 here, just like the quadrants, and 270 here. Tangent starts at 0 and then approaches an asymptote. Goes on up to infinity. Then it comes from -infinity, hits 0 again at 180, and then again keeps going all the way up into infinity, and you got another asymptote here. Then from there, again, it's coming from -infinity, and then it's going to hit 0 again. So what I can notice here, right, is that guess what? Tangent is 0 right here, and that's the same thing we got from calculator. But I also noticed that it hits back 0 right here. Boom. But I also noticed it hits 0 right here. So initially we take from 0 to 360, we got 3 different spots in which tangent theta is 0. But I got to be careful. When I check back up top, they said also equal to 0, but not equal to 360, because you see there's no underline there. So then that means that the ones I'm going to use are going to be 0 degrees, boom, and 180 degrees. Nice. So these are going to be part of our answer. So we took care of that. We got those angles. So now we're going to need to go to the other side, right? And for the other side, we're going to have to bring out our calculator. So let me get the calculator ready, and you get yours calculator ready, and let's get ready to go through this part. So now that we got tan to the theta is equal to -1/2, I'm going to now have to bring up my calculator. So I'm going to go through my regular phone calculator. A lot of you have something similar. And when you turn it to the sides, it gives you the functions. Now, I already set mine up, but you see this arrow right here? When I press that button, it allows me to switch from my regular trig function to my inverse function. So if I have tangent here and I need tan to -1, I'm just going to press that button. Bang. Some calculators might be a second button, but it's going to be something similar. I'm also going to make sure I'm in degrees. This button here represents radians and degrees and how I switch over. So if I press it right now, it goes up top and I see RAD. I don't want radians. Right now I want degrees. So I'm going to press the DEG button for degrees. So now I'm in degrees and I'm ready to roll. So I need tan to the -1 of -1/2. So let me write that out, because that's what we're doing. Tan to -1, I'm putting in the value, which is -1/2, and then it's going to spit out my theta in degrees. So we're going to go there. Tan to -1, and it's also known as arctan, so you see there's a tan there, of -1/2. So I'm going to do -1 divided by, same thing as half, and it gives me that angle. Awesome. So tan to -1 of -1/2 is going to give me theta degrees is going to be equal to -26.56505 11771. I know what you're thinking. Why are we writing all these numbers? Didn't the calculator just say like all I need to do was to the nearest tenth? I know, but this is not your final answer. They didn't ask you for a negative degree. They said from 0 to 360. So what I need to do is find a coterminal angle. See how all the skills are coming together? So coterminal angle. If I'm in a quadrant 4 and I got a negative, I'm just going to do 360 degrees plus negative 26 point such and such. And since it's already in my calculator, I'm not going to have to write it out. I'm just going to add 360 to that to get my coterminal angle. Plus, whoops, let me do back. Let me close, press equals. And then I'm going to do plus, plus 360. Enter. So then what I'm going to get is theta equals to 333.434948829. Okay? Do you have to write all this? No. You can hold it in your calculator and do the work from there. Cool. So from here, I know I have an angle which is somewhere in my fourth quadrant because we go 0, 90, 180, 270, and right back to 360. So I got an angle that's in the fourth quadrant, somewhere right here. Does that make sense so far? Cool. So now that we know we have an angle that's in the fourth quadrant here, that's going to be one of my first answers. So theta is going to be equal to 333 point, round to nearest tenth, 4. I'm going to go ahead and circle that. So far I know I got 1, 2, 3 answers. But again, even though I got this answer, I got to check back up top. They said find all angles from 0 degrees to 360 degrees. So I got to see, is there another angle that can have that? Possibly. Well, I do know from before that we said when we're looking at the signs of trig functions, we can say all students take calc or all students take care. So that means that all trig functions are positive in the first quadrant from 0 to 90. That means sine is positive from 90 to 180. Tangent is positive from 180 to 270. And cosine is positive from 270 to 360. So if we're in this quadrant and we were dealing with tangent, is it positive or negative? That's right, it's negative. And we could already tell it's negative from looking at it was negative 1/2. So I need to find another quadrant in which tangent is negative. Which one would that be? That's right, it's this quadrant right here. I could already tell right here that this quadrant here is going to be negative because only sine is positive. So if I find my reference angle, I can use my reference angle to find another angle in quadrant 2 that will also have the same value of tangent. So reference angle from quadrant 4, see, you combining all these skills, is going to be equal to 360 degrees minus 333.4 degrees. Plug that into my calculator. I'm going to do minus 360. In my calculator, I did not round. I wanted to keep it at that length. So it's going to be 26.56505117771. And this is my reference angle. Very clear. My reference angle is not the answer. It's just what I'm using to find my other angle here, right? My other angle here, which is also going to have a tangent that's equal to negative 1/2. My last step, I'm going to use my reference angle. It's going to be 180 minus 26.565 ... and I'm plugging this into my calculator, and it's going to be plus 180, enter, and I'm going to get 153 point, round to the nearest tenth, 4 degrees. So those are all my answers. 0 degrees, 80 degrees, 33.4, and 153.4 will all satisfy this equation. Now that was a lot that we just did there to solve that. So let's recap what we did, and we can begin to analyze some steps. Okay? First thing that we did is step 1, substitute. We basically substitute a variable for trig function. I'm just going to give you some abbreviated steps, right? Substitute for a variable for trig functions. Then step 2, we're going to factor and solve. After we factored and solved, so let's look at that. Substituted the x, we factored and solved. Cool. After we substituted and solved, we substitute again. Cool. And then after we substitute again, what was our next step? We factored, we solved, we substituted again, and then once we substituted again, then we had to go around and find our angles. So we use inverse trig. Just going to abbreviate that, and just trig functions. And we know that's the stuff like sine to the -1 of theta, or you'll see something like arctan. Both of these are saying the same thing, either or. And then after that, if need be, we'll find a coterminal angle. And then after that, last but not least, we use our reference angles. Okay? Within that, when we find a coterminal angle, if need be, for only certain situations, we may need to use the graph. Okay? If we need to use the graph to help you out, I'm going to go ahead and show you the other 2 graphs now, and then you'll be set to try out one on your own. So I'm going to put all 3 graphs here, and then I want you to use all these 3 graphs, keep them in a safe spot that you're going to refer to later on that you can use all the time. Okay? So first, let's talk about the tangent graph. Of course, it goes on and on and on to negative infinity and positive infinity, but I'm just going to show you one cycle. Got 180, 360, 270, and often you're going to see these graphs are written in terms of their radians, okay? And this one is going to come from 0, then it's going to approach positive infinity as x approaches 90, then come from negative infinity, hit 0, then again approach positive infinity, and the same thing, come from here, negative infinity, and then hit 0. Just like that. This is going to be tangent of theta or tangent of x. That's the basic tangent graph. Let's go backwards now. So now we're going to go cosine theta. Again, you're primarily going to need these for finding when you have something that tangent of theta is equal to 0, so you can know the other values. For all the other values, even actually included one that I mentioned before, you can simply plug into the calculator that arctan function and you'll be straight to find that first value. And the second values, you'll be able to use your reference angles. So, same thing. I got my 180, got my 360, got my 270, and I got my 90. Okay? This is going to go up to 1 and go down to -1. It's going to start here, kind of curve, then switch up the curve, get to the bottom at -1, and take that same curve here, and then come right back up to +1. And if you notice, the way I like to think of it is if I turn that to the side, it's almost like a C for cosine. And then the third graph that you want to be familiar with, right? And you could just keep these on the page, right? You don't have to memorize anything, but you want to be able to access these, right? So that if you need to, you can use them. 1, -1, okay? So then it's going to be half here, Halfway point is 180. Full cycle, 360. Here's my 270, and here's my 90. Again, these values is the same values that separate each quadrant. And I'm doing sine of theta. Okay? I'm going to start at 0. I'm going to curve up and hit 1 at 90. Then I'm going to come back down, hit 180 at 0. Then I'm going to take that curve, hit -1 at 270. And then I'm going to come there. Now, when I turn this to the side, it's not exactly like an S, but it's definitely more closer to the S than the C would be over here. So that's kind of how I distinguish them, because they're somewhat similar. If you shift over this graph by 90 degrees, it becomes a cosine graph, and the same vice versa for cosine, shifting to that. So have these, take a screenshot of these, have these in a place that could be useful for you, and then you would be able to use these if, for example, let me give you a good example of you have something that said cos to the -1 of, say something you had cos of theta equals to 0, and you wanted to find theta, then you would do cos to the -1 of 0 equals to theta. And that cos to the -1 now, I would use that, right? I would say, okay, is equal to 0. It would probably give me back the value, hey, 90 degrees. Because at 90 degrees, theta is 0. But I need two values. I would just go to my chart, go to my graph right here, and I would say, oh, okay, theta is also equal to 270. Because between 0 and 360, that's the next value. Now, these graphs don't just stop here. They continue with this pattern, going on and on and on and on until infinity. So there are infinite amount of degrees in which cos theta is going to be equal to 0. But since they ask from 0 to 360, you get 270. Because there are infinite amount of degrees, the calculator just returns you the smallest one, as opposed to trying to return you all, because it can't do that. That would be infinite. All right, that's it for this lesson. If you have any more questions, you can feel free to ask, and I'll probably post 1 or 2 future videos doing a few more examples.